So what we're going to do is we're going to look at this part here, the 70% of the exam that you guys are taking tomorrow, is we're going to kind of review today. And not really the easy parts of it, because we kind of did that already. We're going to review the harder parts of it. So if it seems a little bit tougher today, it's because we're going through the hard stuff, not the, not everything. The easy stuff I'm kind of assuming you got already. Don't forget to sign up for this Zoom in-person 10-minute verbal exam with me. Go ahead and do that through your link in Canvas. It's not hard. It's basically going to be just the same as your regular exam, going through those problems that are really these problems that are going to be on your exam. So if from your study guide exam 2, only do these problems. These are the only ones I care about. I cut out all the rest because of COVID-19. We're going to focus just on the stuff that I think is really important. And that is also the stuff that you will need to know for that verbal exam. So if you know how to do all these problems and the problems we did last class or the problems we do today, then you're going to be fine. It's just, I might say, you explain to me how to do this. Pretend like I'm one of your classmates. I might give you 2 or 3 problems to explain to me, and I might stop you at some point and have you, move on as long as, I'm confident that you know what you're doing with that. It's just kind of, just a knowledge check and making sure you're on the right page with everything. Okay, so this is the stuff from Chapter 3 that's important. First of all, are there any questions? So speak up, ask me questions about the exam. Do you guys have any questions about it? It's fairly similar. There will be a couple of changes in that last class. I had you guys write down everything, and what you put in the boxes really didn't matter that much. I mean, it mattered in the sense that I kind of double checked to make sure that the answers were the same as what you turned in. But this one is really important because half of the exam, I'm not going to see your work. You're just going to, whatever answers you put in, that's what you're going to get graded on. So it's really important that you input all of your answers into those little boxes, right? It'll say something in red, like answer, and then it'll give you the box, and it's really important you fill all those in with your answers. Because that's how I know, that's what I'm going to be grading you on. And it should mark you theoretically correct. If it's correct, I will go through them in case, for some reason, you type in the wrong thing. Some of them are multiple choice. The multiple answers are just text boxes. So if you put, like I had to put every possible answer. So if the answer is 0.4 pounds, I'd have to code in 0.4, 0.4, 0.4 libs, 0.4 libs, 0.4 pounds, 0.4 pounds, and say you, for example, for some reason capitalized your pounds, it would mark it wrong, even though it's right, and I'll go through those and I'll check that. So just, kind of give you a heads up on that one, that those might be marked wrong and correctly. Yeah.
This is Rizzo. I do have a question. As far as the calculator goes, can we use our TI calculator?
Yes, you can use. Yeah. So there's really only one problem. There's a couple of problems. A couple of them I just threw out, and then there's really only one problem where I really need you to show me your work, and not use the calculator functions. And that one I wrote down. 2 of them actually. I wrote down show me your work. Don't use the calculator functions. So you'll have to show me, if you don't show me your work, then you won't get full credit for that. That's all.
Okay, thank you.
You're welcome. And I think that's kind of it. So the first, 6 or 8 problems, whatever it is, are going to be just filling in blanks and typing them in. You do not have to turn in your work for. The last 6 problems, you need to fill in the blanks and also write down, show your work. And then I'll make you take pictures of those and upload those. And I kind of would like you to, you can do them all at once, like some of you guys put them all on one page. That's fine this time, because I decided it's just easier rather than have each problem on a separate page, just to have them all together. And I'm going to have your whole document, and I'll just grade your whole document. It's just a lot simpler, I found, as I'm going through this. I'm learning, right? This whole thing is a whole learning process for me, and unfortunately you guys have to bear the brunt of my learning. But I'm sorting it out. One thing I do want you guys to do, though, is to save them as PDFs and upload them as PDFs because it's a real pain to have. The iPhone has this HEIC file, which is really, my PC does not work well with it. So if you guys just save them as PDFs, Cam Scanner is a free app. I emailed you guys about it earlier today. It's free on iPhone and Android, and it'll help you take pictures and clean them up and save them as PDFs. So you can just upload them either as one big PDF, or if you can't do that, then 2 or 3 PDFs separately is fine. It's not a big deal. Okay. Any other questions about anything at all? I think I covered the exam more or less. What I need you to, like I said, fill in all the blanks, and the last 6 problems you'll have to also, in addition to filling in the blanks, you'll also have to show your work and upload those sheets. Okay, great. So this is the stuff that's you need to know from Chapter 3. So just mean, median, mode, which you guys know we kind of went over last time. Weighted mean, which we will go over a problem or 2 this time. The 5-number summary box plots, which I think we went over last time. It's fairly straightforward. And then standard deviation, we went through that last time. Empirical rule, which I think everyone gets pretty well, and z-scores. And then from Chapter 5, so we have 2 different types of distributions we talked about. One was the discrete probability distribution, which are basically those tables you make that are, the x's and the y's. I think I have some here. Like this one down here is one, oops, at the bottom. So this would be one example of it, right, where there's a whole bunch of different possibilities for answers and then the probabilities for each of those. So that's a discrete probability distribution. And I'm only going to make you find the mean and expected value. Incidentally, the mean is the expected value. Those are the same thing. So if I make you find the mean, and the mean is 2.3, and then I later on ask for the expected value, just write in whatever you found for the mean. Just write in 2.3. These are the same thing. I just want to check, so that's just me checking to make sure you realize that those are the same thing. So if I find how you find the expected value, and later on ask for the mean, you just write whatever you found for the expected value. The other distribution we found in Chapter 5 was the binomial distribution, right? So I'll ask you to find the probability, cumulative probability, mean and standard deviation, which we talked about a little bit last time. We'll do some more of those today as well. And then Chapter 6 was the normal distribution chapter, so I'll have you find areas underneath the curve and applications of that, and the central limit theorem as well. Okay, so really no questions at all? We're going to fly through this and have all sorts of time left over at the end. All right, so this is the key thing, and I kind of made this sheet up. I think it's a little bit clearer than what I had before. So there are 4 kinds of distributions. Maybe I will give you guys this sheet first. Hold on. Let me give you this, and we'll kind of walk through it. Maybe. There we go. Okay. So the first kind I might give you is a probability distribution. It's a discrete probability distribution, so it's where you get this sort of table, right? So that's the first possibility you might get. And I might give it to you either as words with the percentages, and have you fill out the table, or I might just give you the table itself. So that's where I just say, here's the distribution, there you go. Someone last class asked for a sample of that, so I am now prepped for that. Here's an example of what a problem like that might look like this, right? Felicia, can you go and read this for us? Or Rizzo, read for us. I know you're there.
Quiz problem 1. Let the random variable x represent the number of customers in a small shop at one time. There is a 25% chance of no customers, a 30% chance of one customer, a 35% chance of 2 customers, a 5% chance of 3 customers, and a 5% chance of 4 customers.
Right, so you would just take these things and fill them into the table. Right, so no customers, x is 0. your probability X would be 25%. Right? Everyone kind of following how that kind of works? And then 30% of one customer, 1, and you put in 30%, 0.3 or 0.30, either one, doesn't matter. Is that everyone kind of on board with that part? The chat over here. Someone wanted to know about the NPR. I'll show you guys that when we get to the, yes, you can use the NPR. Okay, so that's the first one. And I might ask you for the mean or expected value of this. I will not ask you for the standard deviation. The other thing the other kind of distribution we talked about was the binomial, right, this one here. So this one, it's where you have a sample. Like I'm going to switch over to this one first. Let's just talk through the different ones. Okay, so binomial, and that's when you take a sample and all of your answers are only 2 options, yes, no. There is a sample. It's kind of like a whoops, wrong way. It's kind of like a proportion, right? These are sort of like proportions. So there is a sample, but there's no mean, right? Because proportions don't have means. If there is a sample and there's no mean, then it's a binomial. It's a proportion problem. And then the normal distribution is obviously when it says assume it's norm distributed. Then you know it's that basic normal, or it could be that basic normal one. The uniform one we're not going to worry about because I'm not going to ask you that. If it says uniform, it'll be uniform, but we're going to skip that one for this exam. So if it says normal, it could either be a basic one, or if there's a sample, it could be a central limit theorem one, because central limit theorem is a subset of the normal distribution. So if it's a sample with an average, then it's central limit theorem. If it's a sample with no average or mean, then it's binomial. So let me kind of make sure that we're clear on this one. All right, so sample with no mean, binomial. A sample with a mean or average, then it's central limit theorem. Because this central limit theorem is a specific case of the normal distribution. Right, so you can either get, if it says a normal distributed, it's definitely going to be normal. It could be basic normal, or if there's a sample, so in other words, you have an n. That's the biggest clue that you can find, is that if there's a sample size n, if you have a sample size n, and it's normal, it's central limit theorem. If you don't have a sample size n, and it's normal, then it's just the basic normal. Is that sort of making sense for people? So there's just different ways of figuring this out. This top one is pretty easy to sort out, right? If you're given a whole, if I just say, here's the data, there you go, that one's pretty straightforward. So then these 3 are the other options. One is if there's a sample, if you have a sample size n, it's either binomial or central limit theorem. If it has a mean, it's central limit theorem. It's just like chapter 8 stuff. If it's going to be that, to find your z-score, you're going to divide by, s over square root of n or sigma over square root of n. It's that thing going on. If it's a sample and it doesn't say mean, then it's binomial. Then it's like a proportion, right? Just like you found in chapter 7 and 8. If there's no mean, if there's no mean, it's binomial. If it's not a sample at all, right? Because the one circled in blue and one circled in purple are samples. If there's no sample at all, then it would be either normal or uniform. If it says normal distributed, it's normal. If it says uniform, then it's then it's uniform. But again, we're not going to have those. So if it doesn't say, if there's no sample size. The easiest way to tell if there's a sample is you'll have a sample size n. That's the easiest way. And if it doesn't, then and it says normal, then it's just the basic normal one that we've been kind of going through. Okay, so do you guys have some questions? We should sort this out, because this is the hardest thing. What I'm finding as I grade exam 3 is that people who are really good about paying attention with me about how to figure out what kind of problems are which did just fine. Some people who weren't so good, and they took a proportion that was a confidence interval and they changed it somehow into a mean, and they tried to unsuccessfully, and they made it into somehow they tried to do a hypothesis test on it. They got 0 points on that problem, right? Because nothing was right. So it's really important to make sure you understand. Once you know what kind of problem it is, with your little formula sheet, you guys should be in good shape. You should be all over this and should be shredding this. The tough part is figuring out what kind of problem it is. And if I'm asking any sort of probability, it's going to be one of these 4 types of probability distributions. It's either going to be a discrete probability distribution, where I just give it to you, or it's going to be a sample that does not have the word mean or average in it, so then it's going to be binomial. And how do you know it's a sample? Because it will have a sample size n. That's the key. If it has a sample, and like I said, the easiest way to tell if you have a sample is if you have a sample size n with a mean or average, then it's going to be central limit theorem. And if there's no sample size n and it says normally distributed, then it's normal. If there's no sample size, and you won't have any other problems. There won't be anything else. And it's unless it's not a probability problem, right? It might be a GPA problem or something else. But in terms of if I'm asking you what kind of probability for a probability, then it's got to be one of these types of things. Okay. Questions? You guys still there?
Yes.
Okay. All right. So let's go ahead and try to sort out some different problems. Now here's one from last class. Okay. So what kind of problem is this one? Take 15 seconds on your own. Don't say anything out loud, and try to figure out what kind of problem it is. And then type it into the chat privately. Do a private message to me in the chat, so everyone else can't just look at your answer and say, oh, it must be this. So private chat to me, what kind of distribution you think this is. I'm getting no answers yet. I have 3 answers. I think there's more than 3 of you. Just take a stab at it. It's okay if you're wrong. No one's going to know. It's totally secret. All right. So I have 6 answers, 7 answers. Okay, good. All right, cool. So you guys have caught on to the fact that it says normally distributed. That's awesome. So you know it's either got to be a basic normal one, or it's got to be central limit theorem. If it's central limit theorem, it will have a sample size n. So find your sample size n. Look for the sample size n. Do you guys see it? Yeah, there's no sample size n. If it's normally distributed and there's no sample size n, then it's just basic normal. Does that make sense? Okay, good. So this is just a basic normal one because there's no sample size n. Let me give you another one. Okay, this is a good one. All right, I'll take out that part. So now, take 15 seconds, and then when you know this one, go ahead and type it into me privately. So it's not about the mu. It'll always have a mu. Normal will always have a mu. I made that mistake earlier talking about that. The normal will always have a mu. Normal and mu go together. So let me kind of show you. Yeah, we're doing B. Right, so normally distributed, looks like people are on it, and there is a sample size of 9. So this is central limit theorem. Maybe I should give you guys a little diagram. So here's the thing. Here's some options. As sample size ends. There's another possibility. Says normal as mean. Oops. Okay, so this is, I know. Ha. We'll do this. So, a binomial, we'll say yes here. And no there. A normal, basic normal, normal, we'll say no there, and we'll say yes here. Whereas a central limit theorem, we'll say yes to both of them. Ha! Oh, that didn't work well, did it? Okay. That's fine. Okay. So binomial will have a sample size, but it will not say normal or have a mean. Basic normal will not have a sample size, but will say normal and will have a mean. Central limit theorem will say yes to both. Is that clearer? Hopefully that's clearer. Okay, good. So that's I should remember this. I should take a picture of this to put in my notes for next semester. Okay. Okay. It also helps that you guys have had chapter 7 and 8 already, so you're really tuned into this saying mean and not saying mean. But at any rate, there we go. All right, so here, this is one thing you can do. See how you know this is normally distributed? Once you know it's normally distributed, then ask yourself if there is a sample size n. There isn't. This is the first one we did, so it's not central limit theorem. It's just a regular normal distribution problem. This is the first one we did a second ago, which I didn't. I should have shown this slide because this would have been a better way of going. Okay. And then we just did the second one. We didn't do that one. Okay, so this one, this was the first one we did. right? Which was normally distributed. There's no sample size n in here. Let me jump around a little bit more so I don't give you guys kind of all the bits and pieces. How about okay, everyone close your eyes for a minute. Don't look at all. Close your eyes, close your eyes. Okay, open your eyes. What kind of problem is this? Take 15 seconds and then type it into me privately.